Hey, welcome to lesson 8.2. This one's going to cover the law of sines, and I might have to split it in two parts because it can get long. All right. So this one's going to cover SAA type of triangles, ASA type of triangles, and SSA type of triangles. So before we proceed, let's talk about these triangles and then what they look like real quick. And this is a review from geometry. SAA, if you notice, this one has two angles available and one side is going to be available. So if I were to draw triangles, one of the sides and then two angles. If this is angle 1, that's angle 2. Also notice the side is not sandwiched between the angles, and hence the side's going to be on the outside. So it could have been this side, it could have been this side as well. It just could not have been this side whatsoever. All right. Then comes in the second type, which is ASA. You can see the side is sandwiched between the two angles. So if I know this angle and that angle, then the side that will be known will be the one between the two angles. And the third type is the SSA, so side, and a non-inclusive angle. So it could be this angle that could be known to us, or it could be this angle that could be known to us, but it cannot be this angle because that angle is sandwiched between the two sides. So this basically becomes the SAS type of triangle. So no, we're not looking for that. An angle has to be non-inclusive. Now, if I look at this, it's called SSA. I could also call it ASS. Yes, I know, now it becomes an actual English word. But if you want to remember it this way, it's okay because this one kind of stands out and this one can be a little tricky. So we'll get to that part. So those are those three types. Then we could also have the SSS type of triangle in which all three sides are available to us, but none of the angles would be known. And then the other one would be SAS, which is side. So side, and an inclusive angle. Those are the five major types. And if I were to show you the picture properly, here we go, five main types. Now these three are the first three that I mentioned. These are the other two I mentioned. What happens is we've got to keep in mind that these three are the cases that can be solved by law of sine. And the next two triangles, the SSS and the SAS, they can be solved by law of cosine. Law of sine will not work for the second two types. So since this is 8.2, our law of sine, we're going to be talking about these three type of triangles. And I think in the first video I'll cover these two, and the second video I'll cover that one because this one is special. It takes longer and it's got some special cases going on. So let's start with ASA and SAA, which is the ones that use law of sine. Now here comes the formula for law of sine. In any triangle, where angle A, B, C are stated as uppercase letters, and then side A, B, C are listed accordingly. Like I said in class, the side opposite to angle A would be marked as little a, and so on and so forth. In that situation, the law of sine states that the sine of angle A over side A will be proportional to sine of angle B over side B, which will be proportional to sine of angle C over little c. And depending on the question, we could be using this proportion, or we could have to use this proportion, or we could have to use this proportion. It just depends on the question. Now, there's an easy derivation to law of sine. I'm not going to be covering that in that video, but I can always show you it on the side. How law of sine was derived. It's not hard. It's very easy, and you kind of know it, but we just haven't put it together. So let's go ahead and start using these. Here's the first one. Like I said, I'm going to cover SAA and ASA. Both of these are the type that will use law of sine, law of sine. So here's the first example, using the law of sine to solve an SAA triangle. And this is especially marked as SAA. No figure has been given, so I'm going to do my best and create that. Notice how two angles are given. That's the easy type, because if two angles are given, I can go ahead and find the third angle right away. And then side A is 4. So this is the information given. When it says solve the triangle, like I discussed in class, we're basically trying to find all of the missing sides and angles. 40, 60. C is what we're trying to find. A is 4, B and C what we're trying to find. So clearly the first step is to find angle C. And angle C would be equal to 180 minus 60 minus 40. That turns out to be 80 degrees. That was a piece of cake. We are done solving that. Second step would be to find angle side B and then find side C. Now the law of sine states sine of an angle. The way I explain and the way you can look for it is begin with the side and the angle that you already know, the pair that's available to you. The sine A, angle A and side A are available to me. So you're going to start with that. And we can choose to work on finding side B first. So if you notice, the other pair, one of the angles or one of the angles is available. So I'm going to use B over B. This will help me find side B. Reason being, we know the value of sine A, we know A, and we know sine B, which means 3 of the 4 are known, hence we can find the 4th one, which is the unknown. Let's go ahead and start substituting. Sine of A is 40, A is 4, sine of angle B, which is 60 degrees over B. Now to find B, I would cross multiply and divide by this, which is the same as cross multiplication, but it saves you an additional step. So B is actually equal to 4 times sine of 60 divided by sine of 40. Okay, now this is ready for the calculator. I'm going to plug it in. Make sure your calculator is in degree mode and not radian mode. I just turned on my calculator and it is in radian mode, so I'm making sure that I'm converting it to degrees. And then time to plug it in. Sine of 40. And that turns out to be 5.38. Let's do the rounding to the hundreds. So B turns out to be 5.39. And I go ahead and finish up this part. And that was the second step. Now for third step, also know that this triangle was not a right triangle, and hence I did not mention about using SOHCAHTOA. Step 3 is to find side C. And like I said, start off with a pair that's available to you. I'm going to still use pair A. So sine A over A equals, and since I'm trying to find C, sine C over side C. Let's start plugging it in. Sine 40 over 4. Sine C is 80 degrees. Remember we found it there, just didn't label it here, over C. So C turns out to be equal to 4 times sine of 80 divided by sine of 40 degrees. And feel free to plug it all in together at this point in time. One more time, since I'm trying to find C, I'm going to cross multiply here and divide by sine of 40. That turns out to be 6.13, and I have solved the triangle, which is what the question said, solve the triangle. One more time, it's very important, this triangle was not mentioned to be right triangle, neither was any angle given to be right triangle, and hence I could not use SOHCAHTOA. So the next thing you want to try is law of sine. And the biggest clue for using law of sine is that if you have an angle side pair available, in this case, angle A and side A were available to me, most likely, law of sine will work. If you can't remember that, then SAA type of triangle will use law of sine. So if I go back to the original one here, erase all this. The first type, SAA, is what I just covered. Both of these are case ones. So I'm going to show you an example of each of them. The next example is now going to cover ASA type of triangle, where both two angles are given and the side included between them will be provided to us. Here's the second one. Oh, I just did this. All right, here's the second one. And you'll notice how this is an ASA type of triangle. Even if it's not mentioned, when you start drawing the triangle, you'll figure that out pretty quickly. these. I'm gonna call that B, so that's 15. And notice how two angles are given. So third angle should be a piece of cake. That's C, which is not given, but I'm gonna find it in a second here. 5, and then 50. So this should be 130 degrees. Also, the question says solve, which means I'm trying to find the remaining angle and two other sides. 15, and C is, but, and clearly we just ended up finding C, which should be 180 minus 35 minus 15, 130 degrees. So that step is already done. And now to find A, do I know an angle side pair? If you notice, yes, I do know an angle side pair, and that will be your perfect start. So the second thing we're trying to find is A, sine of angle C over C must equal sine of angle A over A. Sine of 130 degrees over 5 must equal sine of 35 over A, which is what I'm trying to find. And if you notice in this proportion, 3 values are known and 1 value is unknown, hence it's solvable. You can multiply these two and divide by that. "30 degrees, one more time, make sure your calculator is in degree mode. Why in degree mode? Because all the angles provided are given in degree mode. So A turns out to be 3.74, rounded to hundredths. Okay. And the third part is going to be trying and find B. I'm going to still start with the known angle and side. Sine C over side C must equal sine of B over side B. This will turn out to be sine 5 times sine of 15 divided by sine of 130. And this is all multiplication division, so you can plug it in all together. 1.69 is what I got, 1.69. And I have solved the triangle like the question asked me for. So this question tells me use the law of sine. On assessments and quizzes, it will not be known. You will have to figure it out. So what have we done so far? We have, let's go back here so that you know what's covered in the video. Okay, number one, these 3 type of triangles will use law of sine, and law of sine is the easier one as compared to law of cosine. So we covered an example of SAA type, and the second example we covered was ASA type. Notice both of them are the type where 2 angles are given. Look at both of them. 2 angles are provided along with one side. But case 2, you can notice how only one angle is provided, and only one angle provided here, and no angles are provided here. But this one's still solvable by law of sine, and that's the next one I'm going to be working on the next video. Okay, so part B of law of sine. Watch out for that. See ya.